Right, okay, that's going. Switch to my my backup mouse, which is the one I use for work. It's not as good. The mouse is a bit... The sensitivity is a bit weird, but I can't be bothered to adjust it because I'm getting a new mouse in like sometime next week. The other thing is the scroll wheel's very stiff. It's not ideal. Anyway, I'm modifying this assembler. No, that's not what I want. I want a Uint 8T. Can I do this? No. Can I do binary literals? I can. Right. We can do this slightly differently. Instead of doing all this rubbish, right? So these are 0 and these are uint 8Ts. And I'm going to use bitwise operations. So this is 0. That is, it's just 8 zeros in binary. So we're not going to do this. Like, that's a comment, right? That's a comment. Instead, you bitwise OR it with 0, which does nothing. So we don't actually need to do it. This again. So basically the idea is we don't need to do... I'm going to leave these commented out. Can't do that? How do I do that? Edit? File? Tools? Options. Ugh. I don't care. I need... I don't want to know what a lambda is. I've never used a lambda. But that's... I want it like that. Does it have... I don't know of JavaScript. I don't remember what I was trying to do. Who knows? I don't remember why I was opening the settings menu. I wanted to change something. Yeah, I don't have a formatter. Thing is, it's so much easier to do this in Visual Studio than Visual Studio Code would be. Oh yeah, that's what I wanted. What's that mean? I guess I don't have it. Well, VS Code, you can click and drag with the scroll wheel. Oh, I've done Alt. That just opens the windows. Anyway. Basically, there's a way of doing it. Oh. That should do nothing. This should go, actually... like that. I think. Right? We want to put a 1 there. What we really want to do here is we want to... that. Wait, but this... you put a number out, it has to be an 8-bit number. Do we assume it's signed? Because I could put it directly actually into lower byte. Essentially. Here we just go... what we really want to go is you want to say out file do that, I think. Or we should actually just do it here. Right? And then we can get rid of this one. Right? No, I'm actually gonna do that. And they're still zeros. But this makes it clear to me, at least, that I can look at this as exactly what they do, because I'm working with underlying bit patterns, not even like bytes, which is why I'm doing it like this. So the point is, we're putting a 1 here. And this just works. It's technically signed. Now it's unsigned. Doesn't need to be unsigned. Doesn't matter. So what I actually want to do here is I want to but we actually don't need to do that because ORing something with 0 is a no-op. It's technically not, because compiler optimizations, I think, could theoretically mess with it. The music I have is, in fact, Turing complete, because I might want to reference it. Should this be an unsigned car, or should I just be using a UINT? I mean, this is... UINT 8T is literally just defined to be an unsigned car. We don't need this. This is the lower byte, right? This is into the destination, so I actually do here need to go. This should be a value from 0 to 7. You know what, I might actually put a check in. Right, this should be from 0 to 7. By construction, it is non-negative. Or rather, if I do any maths with it, the compiler will... If I were to say, basically... Oh no, it should be 0 to 6. No, 0 to 7. If I were to do, say, if... These also should be returning 1, not -1. Oh! It's not in source control. Unless it is. Maybe it does have a Git repository. Basically, because this is an unsigned car, when it does the comparison, it will promote it to an int, because 7 is an int. And that's how C++ works. Even if I went like this. Now it's a short. Basically, this tells... I believe this tells the compiler that I actually want to use the short 7. They might still get... I know they do for maths. If you do arithmetic. If I were to add 1 to reg... So technically here, right? Although this is a car. Although I believe what it will actually do here is it'll take the value of reg, which is an unsigned car. This, which is a car, which may or may not be signed. But it doesn't matter because it's 48. Promote them both to ints. Do the subtraction. Cast the result back to an unsigned car and put it in there. To account for potential overflow or whatever. Basically, it means if you add... If you have 2 unsigned cars that both hold... If you have an unsigned car that has like 128 in it, if you multiply it by 2, you get the int 256 because it promotes it to an int. That's irrelevant here. The point is that because this is because I've told it to be unsigned, it means the compiler knows it's unsigned. It should that I'm treating it unsigned. So if it had the value 255, if it was signed, then that would be hex FF. If it was signed, then it would promote it. Then that would be minus 120. No, it would be minus 1, which is not greater than 7. Because this is unsigned, if it were hex FF, it would treat it as 255 when it would promote it to the int 255. So I'll do that here as well. If this is a pointer, but this is the first... This is the upper nibble, isn't it? Right? Because this is the copy, which copies the... It uses the upper nibble as the source. So I actually want to... Actually, can I put, like... Can I put underscores in? No. You can do that in JavaScript. If you put an underscore and a number, basically underscores are ignored when in numbers, which means you could do things like... You could do something like that to indicate that there are two halves. I mean, I could technically, I guess, go... Actually, I don't know how to do that. Oh wait, so I actually... I don't know, I might need underscores. I don't know what does an underscore do in C++? Other than be useful for... But basically, I could go... If I go... like that. I've defined underscore to be nothing, I think. So does that allow me to go... No. Okay. The idea was that I could put a... I wanted to define a separator, but it doesn't seem to work, so whatever. Where was I? Here. Oh no, here. So I put the pointer in. Now I need to learn how bit shifts work. I've never used them. Then we should... How do you do this? Like that? I need to look this up. I've never actually used them. So left shift. Yeah. Oh, why can I not do bit shifting for double and float data types? Because that makes no sense. But I just want to check that I'm using this correctly. This is so unbelievably additive expression. But the number of positions specified by additive expression. So this should multiply it by like 32 or 16 rather. But in other words, it should shift it. It should double it 4 times. That is, bit shift it to the left 4 times, which is what I want because it's currently a value from 0 to 7. So it occupies the final 3 bits. It's entirely contained in the final 3 bits. And I want it to be the last 3 bits of the upper nibble. So I think this is what I want to do. Don't need to do that. Then we... I guess we're making these unsigned. Unsigned car is technically the same as you at 8T, but I'm sort of treating it as a character. And this works fine because 48 is, even though this is technically implementation like if you did a whether car is signed or unsigned is technically, I believe, implementation defined. I believe is technically implementation defined or something. Or it's not. It has to be one of the. I can't remember. It's like unspecified behavior or something. There's a term for it. But if you just do, well, this reg, technically, I think this is probably signed. Technically, the compiler is not required to assume that this should be considered worked with as signed or unsigned. So if I stick 255 in it and then check if it's greater than 0, I may or may not get true. I mean, if I go like... This may end... This could theoretically end up with 255 in it. Because obviously if this is signed, then it'll end up with the value -1. Because this will get... Well, actually, I think it's probably undefined, because that might technically be integer overflow. But that's the kind of my point. That's what I was trying to say. Anyway. We don't need this bit set. Instead, we just bitwise OR it. I will test this. Now we're into the lower byte. My brother would tell me to use hex literals. Can I go like... this? So basically the idea is to tell the compiler... I think this is how this... I think you could do this. Tell the compiler I want to... Basically, I don't want to promote this to an int. Then do the operation and then cast it and then turn it back into a car. Because that's completely unnecessary. Wait. Having said that, it doesn't matter. There is a logic to why I did that, but... The only potential situation in which it would matter would be if I would go for some serious optimization, and I don't... The compiler's probably... The compiler, right, might even be... I would not be surprised if like, GCC or whatever I'm using by default, I don't even know. Or care, really. Doesn't that really matter? Probably could see this and say, this is a uint 8t, you're bitwise ORing it with the constant 8. So, it could just treat this as a single byte anyway, right? It doesn't need to, because it, you know, right? So otherwise... bit shift it left 4 times, then and I've still got that unassembled file, and I'll reassemble it, bung it in, and this is going to output, I imagine. These are unsigned, so they'll just get stuck. They'll just get chucked out as decimal integers, which is fine. Turing Complete will interpret them correctly. Then we just do that. I'm putting these in for clarity, but there is no reason. Basically, bitwise ORing something with 0 doesn't do anything. This should be... like that. If I put an extra 0 in, that would be silly, because then it's 256, which is far too big. This is 128 as opposed to minus 128. And again, it doesn't actually matter, strictly speaking. We're in the lower byte now. We are... What are we doing here? Bitwise operations. I've already done the destination. So they do need to do that. Then we don't need to bit shift it. I think actually I can in the debugger tell things to be in binary. To be like that. Yeah. My brother might be like, oh, you don't need to put... My brother would probably want me to use hex literals here, but this, to me, makes it clear exactly what I'm doing. Right? The point is, I'm bitwise ORing it with a binary expression. And this is why I'm using a binary literal, because this is absolutely clear I'm setting that bit. Is it? That's a bitwise not. How do you do? Is it that? Maybe. I think that's a bitwise XOR. It's not a bitwise XOR. Maybe it's I don't remember. Oh, unless it's that. I don't remember how you do it. I've never really done any bitwise operations, bit manipulation before. Upper byte. Seven. Yeah. You're in the lower byte now, yeah. There's no good formatter, like auto formatter for this. Just a bitwise or with 4, of course. Right. Let's try this. So we've got this test file again. That's what it assembled to before, but hopefully it assembles correctly now. Compiler warnings! I'm doing this wrong, is what it's telling me. I need to do that. Line 102. Line 151. Yeah, it's not going to be able to find it. Yeah, that makes sense. 229. This takes this value, bit shifts it left by 4, and then returns that value. That's this expression. It doesn't modify that. This will give you rage multiplied by 16. It won't actually. It'll give you rage bit shifted left 4 times, which isn't necessarily multiplied by 16, because it could stick out. It could come out the end. But this means bit shift it left 4 times and assign the result to it. Isn't there a way? Oh, can I only have it in hex? Why can't... Oh well. Never reading characters as string. That's because it doesn't exist yet. Oh, it gets initialized. This is uninitialized. To CC. Wish I could view this in binary. They're both 0. This should stay as 0. It's a 3. So it's the value... Oh, because it's a... Oh. That's annoying. Where did I put it? Lower byte. Because this is an unsigned car... It extracted the first character. It's the only time I did that. Probably. So I actually need to do this differently. I need to instead go... you put a negative in, then you get garbage data. I'm fine with that. The compiler may not be happy about this. Oh, it didn't complain. Even though I am... bitwise oring a... What? Oh, it's the comparison because this is technically an overloaded operator. I don't even know what that means. Destination. That, yeah, CCC. Why does it initialize everything to that? So 1F. What? That is 31. Because 0, 1, 2, 4, 8, of course, it's 16. If you add one more, it would go over to 2, 0, which would be 2 in the upper nibble, which would be 0, 0, 1, 0, which would be 32. Yes, so that does make sense. The maths didn't work in my head. So this is a copy instruction. Oh, it's now a bracket. So what is reg? 0. So it should stay 0. Yeah, it does. They get reinitialized. The reg is a 2, which is 32, so we subtract... Oh, it's not 32 because it's in hex. Of course. This isn't going to work. I've just realised it's going to print a bunch of characters. I'm gonna have to do another test. My bit shift isn't being used. I think, oh, maybe it's here. No, it isn't. Yep, and here we go. Printed a bunch of garbage. That looks jank. What does it do? No, I want that operator. Yeah, okay, so I do need to basically go... Oh, but I'm only doing it once, so I'm just going to static cast it. Which means I need to remember how to static cast. What that does is that it tells the compiler that I want to... and this actually will turn into runtime behavior. Basically cast this to an int. Have any complaints? And there we go. That's what it's printed. Zero 31 41 0 66 9 74 9 97 10 134 9. So it printed the same thing as before. Now I need to flip in app data. Schematics. Where is it? Python. Binary eraser. Where is it? Right. There we go. If I do that, it'll have data in it. But it has the wrong data in it. Look at this. Right. So this should... Where's my actual file? I closed it. Why did I close it? So I just want to test that this is doing the right thing. So we should immediate 31 into here. Copy it into here. Yeah. Add them together and put it like here, I think, right? 62. Then we should subtract 31 from 31 and put it there. And then we're supposed to bitwise OR this with that and put it here. So that should go to 31. And then if this is greater than or equal to 0, we should... which it is. Which we test this. And then we should look at this RAM address, which is 0. And jump execution. Back. Which works. We do val 2. Subtly changed it. Copy. Right, this time. So it should bit shift. So we should get 32, which is that. So I've changed my assembly slightly. So now it's supposed to write 31 to there, then copy it to here, then add this to the value at that address and put it there. Now I've changed it, so it's now supposed to subtract the value at this RAM address. No, yes, from the value in this register. So it should now do 62 minus 31 and put it here. So it should now put 31 here. Good. That was because I needed to test the bit shifting. And then it should bitwise or the RAM 31 with 31 that'll be 0. So it'll bitwise OR 31 with 0 to get 31. And put it there. So then that should end up with 31 as well. And then we should jump to 0. Yeah. And then we had a... Yeah, eventually it runs into garbage. Right. That's the assembler done. I think, for now. Which is much easier than... So, you know, I could build it. It should give me... And now I should be able to not need this, and I should just be able to build it. So if I were to... So yeah, this is my thing. And there you go, it's assembled it! Right, okay, so now I can write... I'm going to keep this open. Now we can go back to the actual game. So the question is, what am I actually trying to achieve here? Can I move backwards? No. I don't know how to... What does that do? Like, this is such a... I feel like I'm missing something. You lose if they reach this. Okay, so that's how you do it. Okay. So if we were to say go... Because I'm just going to task this. Wait, no, that's actually wrong. We need some comments. So what do we want to do, essentially, is we want to... I'm just going to flip and build a task. So then we go... Then we turn right. 1, 2, 3, 4, 5. Then these loops. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right. There you go. That's my TAS. Now... Oh, that resets. Of course it does. I need to program to do that. With loops. Right. We just move thing to the output. So for immediate, right, we send a 0 to make him turn left. I only have 128 instructions. Which actually... I don't even need loops, do I? Actually, I might. $88. No, I don't even need a loop. Should all fit. I know what use action does. Five, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. 5, 6. It's a task. Just build a task. That's oddly satisfying. We can double and halve things easily with bit shifts. Although I haven't implemented bit shifts. Okay, so what am I actually trying to do here? What does that cause this to do? I just want to... I'm keeping the... preserving my assembly files. Because I want them later. Okay. I think what I want to do... I mean, the obvious way to do this is to binary search it, right? It's an 8-bit value. So we start with... I've only got limited space in my program ROM without building... I want to try and do this without upgrading the computer, really. Basically, because I only have... how do I want to do this? Right? Because obviously we try. Presumably the input's just 0. Oh no, except sometimes. Oh, I'll do this one because it's free. Basically, we have to reduce modulo 4. You just have to bitwise and it with 3. Because we just only care about the last 2 bits. So we put 3 in there. And then we want to bitwise I think that's correct. It's even called binary search. Right, so the input. Oh, wait. First of all, we store 3 there. I know what the input is. We put 3 in there. And then we... Oh, because it completes. I'm going to modify this. Hang on. There we go. Okay, so the first thing we do is we put 3 in there. And then we put 28 in here. And then we should bit, which is modulo 4 is 0. Guys, again. I want to check that it's actually correct calculating it properly. So now we should be bitwise anding 28 and 0. No, we should be bitwise anding it with 3. Why am I bitwise anding it with val 3? For some reason, I was putting 3 in here, putting the value in here, and then I was bitwise anding this with this register, and it should have been... yeah. Right. This one is, in fact, a binary search. Surely I need to divide by 2. Because my thought process essentially is... it's clearly a binary search, right? So the basic idea here is that you check... I mean, you could... I can't use the overture because it... Do I have a tick limit? I could brute force this without a binary search. Using a loop. Basically, I could just brute force it with a loop anyway. Wait, I need to preserve my unassembled. What was that? We rely on the fact that everything gets initialized to 0. Right? So what I really need to do is we copy oh wait. This might work. I'm unsure. The idea is to brute force. We put 1 in there. And we check 0. And it wasn't correct. Then we add 1. So now we're on 1. And then condition true. So we jump the program counter to 0. Yeah. My first thought was a binary search. To prove the fact that I can't just immediate every value from 0 to 255 to the output. But you were clearly supposed to... Okay, I can get a... Where's the exit? Alright, as always... I'm going to keep my code for that. Maze. Comments. Right, so we need to... 1, 2, 3, 4. One, two, three, four, five, 6. One, two, three, 4. One, two, 1, 2. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. One, two, three, 4. Wait, I need the manual. First is first. $56, I could just TAS it directly. 2 to turn right. Zero to turn left. Oh, okay. Okay. The obvious solution is to hug the left wall. Okay, what I think we're going to have to do instead is actually be slightly more creative. So each step we will... First of all, I could put jump instructions in, but that would be very confusing, complicated to implement. So I'd just have to remember them. Unfortunately, this doesn't have line numbers. I should download Notepad++. It would be much easier. We've got line numbers down here. So we immediate... I could... I don't need to. Oh, but then... First thing we do is we turn left, and then we check if it's a wall. Then it's a flipping coin. But there could theoretically be a thing blocked by a coin. But that's nothing. Oh, it's still a wall. My basic idea is we look left. We're going to try and hug the wall. If we always start at the bottom, I might have to fix it. That's the solution to good programming. You might have to fix it later. That's a later problem. If they thought of it, then I'll have to fix it. Then if it's a wall, so we actually then need to copy the input into that register. So now we know what we're looking at. I can't do a literal one, which means we need to start things off. So I guess then we say we're going to subtract 1 from value from register 1. We can put it in. I'm going to put it in 2 just because I'm going to use the spare register rather than clobbering the existing one. Then it jumps to a register, doesn't it? So if it's not equal to if val2 is not equal to 0, we jump to I need to put 2 somewhere. I haven't used 4. Because this instruction is 4 and 5. Why am I outputting 0 to the... Oh, to turn left. So if it's not a... The idea is he's going to turn left until he finds a wall. Then he will turn right. Go forwards 1. And then we repeat. Oh, wait. That's to go register 3. And we jump to that register. So we turn left 1. Check if we're facing a wall. And if not, we go back, turn left 1, and we keep turning until we face a wall. So this will fall through if we weren't facing it. If we were facing a wall. At which point we should turn right, and go forward 1. Then we need to jump to... This might work. I'm not sure. Okay, this is the goal. So we put a 1 there, and a 4 there. We turn left once. We did not turn left once. Maybe he turns left once on the next. He hasn't actually turned. Okay. We put 1 in there. Then we put 4 in register in valve 3. Then we put a 0 to the output, which makes him turn left, but he's not actually visibly turning left. Then we copy the input to register 1. Then we should subtract this from that and put it there. Right. Or -1. It's irrelevant. And then this is not equal to... And then we should check if this is equal to 0. And if not, we should jump to instruction. We should put 4 in the program counter. It isn't equal to 0. So we put 4 in the program counter. Which should make him turn left 1, in theory. Yeah. Okay, now he's facing the correct way. And we put 1 in here. Then we subtract this 1 from that one and put it in there to get 0. And now we should be checking if 0 is not equal to 0. Oh no. Okay, we're doing the subtraction of 1. Then we check if 0 is not equal to 0. Wait, what's this doing? Okay, I need to modify it slightly. So here, we turn left 1. We turn right 1. We actually need to turn right until he's not facing a wall. So we turn right 1. And then we have to... which needs to hold 0, 2, 4, 6, 8, 10, 12. Whoa. Where is he currently? He's doing copy val 1 to val 7. So we put 1 in val 0. We put 6 in val 3. Put 12 in there. He moves to the left. He turns left. Put that 0 in there because he's looking at nothing. Then we subtract 1 from 0. Put it in there. And then we should jump the program counter. To move him left again. And then we should copy the 1 to there. Then we should subtract the 1 from 1 and get 0, which we put in there. Did I forget to move it? Hang on. We should have like a 7-2. We should check a condition. I think next. which is false because we're checking if 0 is not equal to 0, which is false. So we should go to the 7, 2, which should output 2, which tells me to turn right once. Then we copy what he's looking at. He's looking at nothing. I was checking if it was turning right until he was facing a wall and then trying to go forward or something. Oh. It needs a counter. Actually, it's just completely wrong. It's now that I think about it. What he actually should be doing... As my comments get stripped. Wait, well, I will need... He should be, but he needs... I needed to turn left. And then, if he's not facing a wall, we fall through, we will go forward one. If he is... Otherwise, he is facing a wall. We turn left. If he's now facing a wall, we turn right until he's not facing a wall. So if he is if he's not... Because I'm going to have to jump forward if he's not facing a wall. Or if he is facing a wall. Otherwise I have to have a skip. So I'm going to have a jump forward. So this is going to go in ridge 3. I need... Because I don't know what address it's going to be yet. Oh, I might need another one. It's gonna be rich 4. So we copy into register 4, register 7. Then so this is a... Oh no. Right, I need to go eat. So I guess I'll come back to this tomorrow or something. Goodbye.